In these examples, we don't quite have, we're going to be finding the areas under the curve of these definite integrals. But what we don't quite have is the math to do it quite yet. That's called the fundamental theorem of calculus, and we're not quite there. So how can we find these areas under these curves just by kind of using some information that we have already, some background knowledge? So the idea behind this is we are going to find the area under the curve of this linear equation from 2 to 4. So we are going to draw graphs, right? We're going to actually create, all of these have a geometric way of doing them. They're going to create triangles or squares or rectangles or some sort of a shape that we can figure it out. So, but we need visuals so we can make the geometry part of this. So if I start off with graphing this thing, then I'm going to go from 1, 2, 3, 4. So we're going to be going from 2 to 4. If I were to graph that, I have a height of 1, right? That's a starting point. And then I'm going to go up 1 over 1. So up 1 over 1 is the next point. Up 1 over 1. Up 1 over 1. Up 1 over 1. Right, so there's our graph to it. And I want to find the area of the curve from 2 to 4. Right, so that's the area. Well, to find that area, I have a trapezoid. So finding the area of a trapezoid is 1/2 the sum of the bases, which are the parallel sides. So here are our parallel sides. So I have a height of 3 and I have a height of 5. So we'll be taking, well, let's write the formula real quick, I guess. So it's 1/2 the height times base 1 plus base 2. And the base 1, base 2 are our parallels, which have a height of 3 or a distance length of 3 and 5. And then the height is the gap between it. So if I were to kind of roll this thing on its side, how tall would it be? It would be a distance gap of 2. And then I'm going to put all that stuff together, and that's going to be my area. So I have an 8. Half of 2 is 1. 1 times 8 is going to be 8. So our area under that curve would be an area of 8. All right, if we do that one, same kind of a thing. We have a linear equation, just a different kind of an equation to it. So I feel like we need a little more space. So I'm going to go from a -4 to 2. So 1, 2, 3, 4. And then I have 2. So rather than me going through all these different pieces, I'm just going to plug in -4 and see what its value is going to be. And I'm going to plug in +2, see what its value is going to be. So I'm going to have a -8 plus 4 is a -4. So that point is at a height of -4 when we're out 4. And then my height at 2 is going to be 4 plus 4 is going to be 8. 1, 2, 3, 4, 6, 7, 8. So its height's going to be 8. And so we need to figure out what the area of the curve is. Now I do know I have a y-intercept at 4. So 1, 2, 3, 4. So that's kind of where my begin and my end is to this. So with a little bit of accuracy, I might want to just go ahead and do my up 2 over 1s kind of. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right, so there's our shape. And the accuracy part to this is I'm going to have a triangle here, and I'm going to have a triangle here. This is below, so I'm going to have negative area here, positive area here, and I'm going to add them together. And they're going to essentially cancel each other a little bit. So if I look at the negative one, I'm looking at negative. So I'm going to have a height of 4. This is a 4/2 triangle. So the area of that is 1/2 base times height, which is going to be 8. Half of 8 is 4. So that's going to be an area that's going to be a negative. I might as well tack negative onto it. And then I have a positive area, which is a triangle. That's 1, 2, 3, 4 by, this was a height of 8. So 4/8. So area on that's going to be 1/2 base times height. So I got 32, half of 32 is going to be 16. So our area is going to be a -4 plus 16. So my net area is going to be 12. All right. And then next video is we'll focus on these two examples.